Hi there. We've closed a critical blind spot now in the Peak platform. So from today onwards, our FDD rules engine can detect the moment a device or sensor goes offline and notify the right people. My name's Howie. I lead the product team here at CIM, and I'm joined by Mike Larson, our senior backend software engineer who worked on this feature.
Morning.
And we're going to go through just a bit of an overview of the feature, its benefits, and an in-depth demo of how to actually create your own offline device FDD templates, how to deploy them, and how to set up automated notifications. So let's jump right into it. So the new feature, offline device detection, is able to detect devices and sensors not streaming to the CIM cloud platform. It covers all sensor points that have been commissioned to Peak, including submeters, meters, critical plant sensors, and importantly as well, the CIM data acquisition device, which we call BESA. Now, how is this useful? This supports operations teams who are looking at using these notifications to detect if any submeters have gone offline, particularly the ones that are used for tenant billing and cost recoveries. It's incredibly important for sustainability ratings to detect if any exclusion meters are going offline, as well as detecting if any critical equipment or devices that are central for asset uptime are also going offline. So I might pass it to Mike just to give a general background as to the improvements we've made to our rules engine to basically support this. Mike?
Yeah, hi. So traditionally our rules engine is predicated on data coming in to execute rules, which we call sort of batch execution as such. So as data comes in from any of our devices, we process the rules. This lets us not execute, obviously, when things aren't coming in, but also catch up when devices are offline, which is quite critical. So we always process rules for data that comes in. The big gap being that if data doesn't come in, we can't execute the rule. So we've now implemented the concept of scheduled tasks for the offline device detection that lets us execute on a schedule to check if specific things are streaming data, and this lets us capture these offline devices and trigger alerts, etc.
Awesome. All right. Thanks, Mike. Now let's jump right into the demo. We'll cover off three things. We'll show an example inside Peak Charts of what an offline sensor actually looks like. We'll go through how to create the most popular FDD templates for offline devices, as well as the best practices we recommend. Also show you how to deploy one of these rules from these templates. And then most importantly, as the end step, we'll show you how to set up an alert notification so that when one of these offline devices gets detected, we're basically assigning it to the right people, notifying the right people when it happens. Okay, so now we've navigated into charts. You can see here we've integrated with the gas submetering on this particular site. We have two of the data points. The cumulative gas usage has been streaming data every 15 minutes. And then we can see here examples of a number of meters down here that have stopped streaming data. They were flatlining for a period of time, and then they went offline for a period of time. So it's these issues that we want to go out and detect. Sites can have thousands of individual sensors and hundreds of different submeters. So being able to detect these offline when they happen in an automated way is incredibly important. So we'll go through some of the new functionality we've released in the FDD rule templates to enable offline detection. The first one we want to go through is probably the most important one, is to automatically detect when the CIM data acquisition device, what we call BESA, has gone offline. So we've introduced two new functionality here. We've got a new shared system metadata called BESA Sync, which basically now tracks whether or not the acquisition device is communicating with the cloud, and a new FDD formula called missing, which enables us to detect if any values are missing within an interval period. Now we'll go through some best practices as to how to implement this right now, so let's jump right into it. So I've navigated to the templates page, and I have open here a very simple template that we can reuse to detect if the data acquisition device has gone offline. So Mike, I might get you to talk us through how you can set this up.
Yep, so super duper simple. We need to create a favorite and point it at the BESA Sync metadata. This is a system metadata that is available on all sites when a BESA is actually deployed. And yeah, it represents when the BESA is actually synced data to the cloud, so it's a perfect thing to use. Then we feed that into the new function formula where we use this missing formula as mentioned. And yeah, it's as simple as it can be. We put in the interval of which we're checking the last X minutes as such from that interval for data, and then the sensor which will autocomplete as expected as the formula. And then the key is the threshold there. Now this missing function, if the data is missing, it will return 1. If the data is there, it will return 0. So yeah, set threshold to 1 if we want to match that it's missing, and go from there.
And then we set finally just the fault gate to basically detect when that is true. It's about as Mike said, this is the simplest rule that you can actually write to detect if it's actually gone offline. And best practice is at the formula level, we'll set the interval at 15 minutes, and we'll show you when we deploy the rule, you can then customize the thresholds at the rule level of how long you want to delay before triggering this. So do you want to wait 1 hour before detecting if something is offline, or do you want to wait 24 hours before detecting if that's offline? Rule. We'll now move on to probably the next one, which is looking at offline sensors. And this is where we'll start using the building blocks of different nodes to reduce the amount of false positives. So this is a very useful one for detecting if there's any offline gas meters, submeters, power meters, or any individual equipment sensors that you're looking at. So we'll jump through an example of this right now as well. So as you come through here, we'll see we have very similar, the same nodes that we had in the previous one. So we've now set this as a precondition. It's basically checking if the baser is online, and to check if the baser is online, we basically just flip the threshold, as Mike mentioned, from 1 to 0. So that now 0 means the baser is online. We set that gate condition to be true. So we want to only be triggering this alert, this offline detection for a gas submeter, if our baser is syncing data. Otherwise, you'll have a situation where if the baser goes offline, you will trigger basically every single alert if it's not getting data, because we're not streaming data directly from the source. So the gas submeter, exactly the same example as before. You can come in, choose any favorite, select any metadata you want that we're streaming for. So in this example, we've used the gas meter, but this could be a power meter, this could be a water meter, this could be a chiller leaving temperature value, or any other point that you need. So we put that as true, and we follow the same formula as we did before. We use missing, keep the period at 15-minute interval, and select the value that we have here. So in this example, we're using the favorite gas submeter value, set as 1, and then that will trigger. So again, super simple, very easy to create gas offline meter template. Now we'll move on to the next example of how to, once we've created these templates, some of the best practices of how should we go about deploying an offline rule. So there's 4 things you actually have to remember once we deploy the rule. It's important that we select the rule type to be scheduled, not batch. As Mike mentioned, scheduled will help us detect any offline sensors. If you put it as batch, they will not execute. There are also some best practices that we recommend for setting these triggers so you don't make it that noisy. We recommend setting a 24-hour trigger for detecting if something's offline, and a recovery delay of 1 hour. So that will be 96 intervals for the trigger, and 4 intervals for the recovery. Also, best practices we recommend for setting these schedules is to set a 24-hour schedule for offline devices. So you may need to override the schedules that you might have for your building schedule. So now I've navigated to the rule tab. So when we create a rule, we've select the template that we've created. So in this particular example, you can search for it. You can quickly search for offline to see all the available offline FDD templates that you can use. In this example, we'll use an offline water submeter. Now, important to remember, we select the schedule tab here, as we mentioned, for any offline devices. Click on the schedule tab. We'll now be able to, through this rule, select the metadata that we actually want to deploy it against. So we might, in this example, be looking at the office master, and then also we'll select the baser device as the precondition for this particular rule. We'll leave the thresholds unchanged here. So at the threshold of 0, we're basically detecting that the baser is online, and that a threshold of 1, meaning true, is that the water meter is offline. It's important here that we come through and set the correct thresholds. So we can see here that the false per alert reflects the number of intervals. So 4 intervals is an hour, 96 intervals will be 24 hours. We'll come through here and select the trigger as 96, so we'll wait for 24 hours before triggering an alert, and we'll set the recovery interval at an hour, which represents 4 intervals. We can also come in when we deploy the rule to override the default priority. So the default priority that's inherited for this template has been P4, but let's say, for example, this is the mains water meter. We care a lot more about it because we're doing cost recoveries, we can reset this to a P2 level priority for any future alerts that get triggered. We'll come through the schedule. As we said before, recommend a 24-hour schedule. So you can see here, this is when it runs. Keep it in schedule. Change it to 0000. And if you click on this double arrow icon, it will load the whole rest. So now we are confident that it's actually now deployed 24/7. So we can click on create another if you want as well. This means that we don't have to go and reset all these settings each time. So we'll create that rule. That was successfully deployed. And now we can deploy it on some other meters as well. So let's say there's 3 meters here that we absolutely want to know if there's offline. We also want to know if the hot water supply has any issues as well. So we'll click on that and notice that all the previous settings we just set on have been remembered, and then we can go through and click create a rule again. So it's that simple for us to go through and create the rule. Now, the final stage of the demo, as we mentioned before, is now how can we set up the automated alert notifications so that the right people are notified when specific offline devices go offline. So really 4 steps that we have to do here. We've already deployed the offline rules, so we need to make sure we've deployed one of those rules. We'll then go to the alerts page to go through create a notification. We'll show you how to filter it and how to auto assign. So let's jump right into that example right now. So go to alerts, to your alerts page for your particular site. You'll see in the top right here, there's a button called alert notifications. Click on alert notifications and click on create notification. We'll create a notification here called offline water meters, and we'll filter it, not for all alerts. We'll filter it on selected equipment and rules. And we're now able to filter it for the new template that we've just created, which was an offline water meter. So we'll select that. We'll select the people we want to notify. And then we can also, as an additional option, go through and auto assign it to a relevant person as well. So an offline water meter, we might send that to the plumber. And we'll click save. So now we'll see an example of an alert that gets triggered from an offline meter. As we go through here, we can see on this particular site, that's triggered an alert. We've picked up a gas meter's gone offline. If we go through, we can customize the description and solution, go through and customize the rule links if we want, and we also have a quick link going into it as well. So we'll just click through that. And we can see it's picked up the alert. We can see that the device is offline, we're not streaming data, we have an NA, and then also the baser is online as well. So it's as simple as that. So I really encourage you guys to go out and have a try of this new feature. If you have any questions, please reach out to your customer success representative. Thanks, guys.